Let's talk about inverse trig functions and some of the review that you might need to do calculus. So let's do calculus with inverse trig functions. Now this is not actually the calculus part, so let me call this part 1 just to emphasize that. Let's take a look at what inverse trig functions are. They are written as things like arc cosine of x, or maybe cosine inverse of x. And the answer to an inverse trig function is an angle. So I'll call it theta, all right? So that's the big deal. Now, when you've got arc or inverse cosine, those are equivalent. It's just that they're two different forms of the same thing. Now, officially, if it's capitalized, there is only one answer. If it's lowercase, there are an infinite number of answers because of the cyclical pattern for cosine, sine, tangent, and so forth. But most books just do lowercase, so I'm not going to worry about that too much. But let's look at an example or 2 or 3 and try to figure out what's going on with this. So just a little bit of review, all right? So some review examples. First example I'm going to take is this one. I'm going to take the tangent of the arc cosine of the square root of 2 over 2. Now, arc cosine of the square root of 2 over 2 is the angle that has cosine equals square root of 2 over 2. I'm going to try to stay in radians here when I need to. So if I've got this, I know that the answer to this is pi over 4. So I need the tangent of pi over 4. Answer is 1. Let's try another one. This one is not something I have memorized. You probably don't either. This one is the sine of the arc sine of 5/13. Now I could crawl into my calculator and punch that out and try to figure something out, but there's a better way to do this, a more exact way to do this. So here's what we're going to do. We're going to create a right triangle in the first quadrant. Now it is not to scale, obviously. And I know that if this is theta, that the sine of theta equals 5/13 because of the way this is written. So if this is theta, then this is 5 and this is 13. So what's this? Well, 5 squared, I'll call this x, plus x squared equals 13 squared. So 25 plus x squared equals 169. Subtract 25. Get x squared equals 144. And we'll use the positive version, so x equals 12. The cosine of this angle is 12/13. So we get a pretty nice answer. Now you've got to know how to do that with some form of this, because calculators don't work for every question that you're ever asked. A lot of times the questions are not numerical. Let's look at another one. This one has a negative in it. Let's find the tangent of the arc sine of minus 5/6. Now, arc sine, if you will recall, is defined in, the answers come in quadrant 4 or quadrant 1. So let's draw this one. A sine is negative in quadrant 4. So this is in quadrant 4. I usually try to think of this, and it almost always works, of the where the sine is negative closest to the first quadrant. Now that is not really sufficient for tangent and cotangent, but it does work for the others. So quadrant 4, I'm going to draw this in quadrant 4. I've got my angle theta, I'm going to call it theta, and it is negative 5/6. Sine of it is negative 5/6. So sine is opposite. So there's where the negative is going to be. And the hypotenuse is 6. So I've got to figure out what the x value is. It's going to be positive here. So x squared plus a minus 5 squared equals 6 squared. So x squared plus 25 is 36. Subtract that, you get x squared equals 11. So x is the square root of 11. And what good is that? Well, tangent of theta is the opposite over the adjacent. So the tangent of theta is equal to negative 5 over square root of 11. So there's an answer there. Now, how do you do this without, when you don't have numbers? Well, it's not too bad. Let's try some other examples. Let's take the cotangent of the arc cosine of x. Try to figure that out. Well, this is, when you've got an x, first quadrant is fine. So I'm going to call that my angle theta. And so I need to know the cotangent of theta. But I'm all about drawing triangles. So I'm going to draw a triangle. And I know the cosine of, I need the cotangent of theta, but I'm given that the cosine of theta equals x, because that's what this means. So the cosine of theta is x. Well, I can state that as x over 1. The adjacent side over the hypotenuse. So what is this side? Well, that's y if you want, so we could talk about that as y. X squared plus y squared equals 1 squared. What's y? Y squared equals 1 minus x squared. So y equals the square root of 1 minus x squared. Now I ignored the plus or minus because I'm in quadrant 1. And everything's positive in quadrant 1. So I'm going to take 1 minus x squared, square root. So what's the cotangent? Well, the cotangent is the adjacent over the opposite. So the cotangent of theta is equal to x over the square root of 1 minus x squared. So there's that relationship. So I think these are pretty fun. That may or may not be your opinion, but we'll see here. And you don't have to do these with triangles, but if you don't, you have to memorize a bunch of formulas, and triangles are a lot better. And I'm using the Pythagorean theorem as we go here. So let me try one more just to get this review kind of going. We've got arc sine, secant of arc sine of x minus 1. Sometimes they're not super simple. So draw a triangle. The sine of theta equals x minus 1 based on this info. So here's theta. Sine is x minus 1. We'll make that into a fraction. Here's x minus 1. Here's the hypotenuse. So we need to know the secant because it's asking for the secant, and that is hypotenuse over the adjacent side. So the adjacent side, and I'm not going to call it x this time because I've got x in here. So adjacent squared plus x minus 1 squared equals 1 squared. So what's the adjacent side? Well, it is adjacent squared is 1 minus x minus 1 squared. So adjacent is square root 1 minus x minus 1 squared. Now I didn't simplify that. You could. It doesn't really simplify terribly nicely. The 1 will disappear, but not too much else. So anyway, I'm just going to write it this way. That will fit any formula that you see written down. So the secant of theta is equal to 1 over the square root of 1 minus x minus 1 squared. So there you go, with a little bit of review of inverse trig function.